Yes, we're looking for year 11. Yes, and the first topic is a periodic table. Periodic table. Periodic table. So let's go. During the course of this class, we will define the periodic law. Then after that, we will look at some properties. We define groups, define periods. Then we'll look at the electronic configuration of these groups and periods. Into the phone. Just stay tuned. Right, so let's go. So there is this Russian scientist called Mendeleev in 1869. Hmm. So this Russian scientist found out that uh, certain elements, yes, the same elements of the same type, they have similar properties, and these properties keeps reoccurring regularly and sometimes at a particular period. Okay, so he decided to construct a table, and that table is was called the periodic table. Although he did that in order of increasing relative atomic masses, right? And while constructing his table, there are gaps. Okay, there are some element that does not have a place in that on that table. Element like germanium, like canadium, um, yes, and gallium and etc. They don't really have a place to they don't have a place to fit them in. But later, with the discovery of electronic structure, it was found out that that um, that this element actually vary not according to their relative atomic mass, but according to their atomic number. Okay, so not atomic mass now, but atomic number, and this gives rise to what we call the periodic law. So let's define the periodic law. The periodic law states that the properties of the elements are a periodic function of their atomic number. So you can see we said that periodic law, we call it the modern periodic law. The modern periodic law states that the properties of the elements are what are a periodic function of their atomic number. Atomic number. So quickly, let's go to the periods and groups. So we will need the periodic table for this. So I'm sure you have a periodic table with you. So if you don't have, please go to New School Chemistry Chapter 8. Yes, New School Chemistry Chapter 8, where you have periodic table families of elements. So you go there, you see when you check that you see your periodic table, okay? You see your periodic table. So I want to define groups. Okay, so let's go. We said the groups, they are the eight vertical columns. They are the eight vertical columns and they are called groups and they are numbered 0 to 7. Okay, so that you have them numbered 0 to 7 or you have 1 to 8. The number is that you have 8 or you have 0. I'm sure you're not confused. So you can have 1, 2, 3, 4, 5, 6, 7, 8, or you have 0 zero, 1, 2, 3, 4, 5, 6, 7. Okay, and they are what the vertical columns. Okay, these vertical columns are called groups. Okay, we said elements in the same group have the same number of electrons. Okay, so elements in the same group have the same number of electrons. What do we mean? We are saying that they have the same number of valence electrons or electrons in their outermost shell. So, for example, let's pick group one. So, in our group one, are we there? Okay, if you're there, say hi. All right. So, elements in the group one, let's see the group one. We have the lithium, we have sodium, we have potassium, first strength elements. I'm sure by now you know your first strength elements. Okay, so you have lithium, sodium, and potassium. So they are all in group one. So when you want to write the electronic configuration for lithium, going to be 2 1. What do we have outside? 1. Okay, thank you. Then for sodium, 11. What do we have? 2 8 1. What do we have outside? Yes, electron in their atmosphere. So it's what we use to place them in groups. Right. So let's go to group. Which other group? Let's go to group 7. Yes, group 7. You have fluorine and you have chlorine. Okay. So you have fluorine 2 7, group 7. Then chlorine 2 8 7, atmosphere, group 7. So that is for their group. So what do we use to determine their periods? We said they are the 7 horizontal rows. Yes, they are the 7 horizontal rows. The rows. Ah, get me. Vertical like this. Horizontal like this. So the horizontal, they are the period, and the vertical column, they are the group. So how do we know the periods? The periods are the number of shells. Yes, the number of shells. So let's count the shell. Let's pick um the first. Let's look at the shell now. What do we want to pick? Okay, let's pick lithium. Lithium is 2 1, right? So let's count how many shells does he have. He has 2 and 1. So your 2 is K, your 1 is L. So how many shells altogether? 2 shells, as in 2 entities. 2 and 1. So count them. 2 and 1. Okay, that is 2. So it's in shell 2. So what about potassium? Potassium is 19. So we have 2 8 8 1 4. 4 is in period 4. So you want to help me with chlorine? Tell me. So you want to tell me the group and the period chlorine belongs to. Let me see the group and the period. You already know the group. So what's the period? So chlorine is 17. 2 8 7. Do you get that? 2 plus 8 plus 7 is what? 17. Okay. If you need more clarification, please let me know. 2 2 8 7. So how many? 1 2 3. So that is the shell. So is in group 7 and what? Period 3. All right. So that's about periods and group, and it's also numbered from 1 to 7. Yes, also numbered from 1 to 7. So quickly, let's go to the electronic configuration in the main and the sub energy levels. Okay, so let's look at the group 1. Quickly, they have s electrons. Yes, the group 1 have s electrons. And how many s electrons do they have? They have just 1 s electrons. Okay, then the group 2 has um, two s electrons. So the group 1 has 1 s electron. The group 2 has 2 s electrons. So group 1 and group 2 are s block, not s block. So group 1 and group 2 are what? They are in s block. Do you get that? Okay, so we said group 1 has what? One what? Electron, 1s electron, and group 2 has what? 2x electron, and they are both in s block. But your group 3, yes, your group 3 has 1p electron plus 2s electron. Are we good? Group 3 has 1p electron and 2s electron. 1p electron plus 2s electron. Your group 4 has 2p electron and 2s electron. Okay, so what about group 5? Group 5, we have 3p, right, plus 2s. Then group 6, I get it. 3p and group 6, 4, right? 4, right? Yes. 4p and 2s electron. Then what about your group 8? Your group 8 we have 6p electron plus 2s electron. So that means that our s has 2. Once it's 2, it's filled up, and our P is 6. Once it's 6, you fill up, you go to the next block. Okay, so let's quickly run through. We said our group 1 and 2 are made up of what? The X block. Then our group 3, 7, and 0. Do you understand? Okay, are made up of the P block and what? The X block. Then in between group 2 and 3, we have what we call the transition metals. Yes, the transition metals. I so much love transition elements because they have beautiful colors. Yes, they have colors. They are the ones that form colored compounds. They form complexes. They have variable oxidation number. Yeah, these are transition elements like your iron. And we have iron 2 and iron 3, like your zinc. These are transition elements. But it is not all of them that are colored though, because zinc does not have color. Your iron has colors, your chromium has color, your copper has color, and their color is so wonderful. Yes, so wonderful. So in between group 2 and group 3, you have the transition metals, and they have S, P, and D. Yes, they have D block. Yes, the transition metals have D block. Yes, that's what we need you to know between the metals and the transition metals. Then you have the lactinite and the actinite. Yes, the actinite and the lactinite are also between group 2 and 3, but in period 6 and 7. Yeah, they are between group 2 and 3, but in period 6 and 7. All right, so they are in between. Okay, so but yeah, they are what? Period 6 and 7. Okay, so your actinite and your lactinite, we have F block in addition. So in essence, you're saying that your group 1 and 2 X block, your group uh, 3 to 7 to 0, they are what? P block. So in between group 2 and 3, you have your transition metals, and they have S, P, and D. And in between your group 2 and 3 is still, but period 6 and 7, okay, you have your actinite and lactinite, and they have F block in addition. So they have S, P, D, F. Okay, so we'll be calling it a day now. Come back later for the next.